This question is from the 2018 exam, so only 2 years ago. And a couple of things I want to point out about this problem. First of all, it says no calculator is allowed. So this is a problem that you would normally be expected to do without a calculator. But as I mentioned today online, we are going to be able, or you're going to be able to use your calculator for those two questions. But there's going to be some things that conceptually that are very, very important in this problem. The first thing I'd like you to notice is that when you're given the graph of g, you want to read very carefully to see what g actually is. And g is defined to be the derivative of f. So I'm going to right away write f prime here so that we remember that whenever we're looking at this graph, it's really a picture of f prime, or the derivative of g. So the y values on this graph correspond to the slopes of g. So the y values here are tied to the slope of g. Now, notice that it's a piecewise function with a series of lines here, and then the last part is a parabola that we are given in this equation right here, and that's only from 3 to 6. So we are given, the first question here is f of 1 is equal to 3. So we have to find out what f of negative 5 is. Now, if you look this up online, you're going to see it done in a different way, but the way I'm going to set it up, I think, is a little bit easier to see. We have f of negative 5 plus the integral from negative 5 to 1 of g of x dx is equal to f of 1. So that if we start at negative 5 and we begin to integrate, then the value that we would get is equal to f of 1. So some of these values were given and some of them we have to find out. Now, if we start here at 1 and at negative 5, okay, so we block off this section of the graph, and then I'm just going to write the areas in here. This would be an area of 9. We're going to decide whether it's positive or negative later. This area here will be 1.5. Here is going to be an area of 1. And so now let's just start with f of negative 5 is what we're looking for. And so we have f of negative 5 plus, from negative 5 to 1, from negative 5 all the way to 1 would be negative 9 plus negative 1.5 plus 1. And then here we know that f of 1 is equal to 3. So now all I have to do is figure out what f of negative 5 is. And so f of negative 5 would be equal to, if we take away 3 minus 1, so 3 minus 1, and then if we add 10.5, right, we get 13.5 minus 1, and so our final answer here would be equal to 12.5. So what is the value? It would be 12.5. 12.5 here. Now, for letter B, we're going to evaluate from 1 to 6. So from 1 to 6, we're just going to collect the area underneath this curve from 1 to 6. Now this part is easy to calculate. This has a value of 4. And then here we need to integrate from 3 to 6 of g of x dx. So we're going to add 4 plus the integral of 3 to 6 of g of x dx. So let's leave that alone for now. But I'm going to bring the 2 out in front. We get x minus 2 squared dx. And what you might be tempted to do is expand this. And this would be x squared minus 4x plus 4. But if you do a u substitution, which we have done before, then u equals x minus 2, and so du would just be 1 dx. Well, we have a 1 dx here, so then the antiderivative of x minus 2 squared is going to be x minus 2 cubed over 3. And we have the constant out in front, and then we're just going to integrate from 3 to 6. So what we have now is 4 plus 2 times the integral from 3 to 6 of x minus 2 squared dx. And then all we have to do is evaluate this. Now, if you do this calculation, okay, we would plug in, you plug in a 6 here, then you plug in a 3, and then you subtract them, and I'll leave that for you to verify, but this would give us a final value of 10. So evaluate this, and you get a value of 10. Now, if you didn't recognize this, okay, if you didn't recognize this, you could expand this as x squared minus 4x plus 4, and then find the antiderivative, which would be x cubed over 3 and so forth. But this is a little bit easier